All right, for this, we need to simplify the expressions. Square root of 10 times square root of 20, the cube root of 16 times the cube root of 20, square root of 15 times the square root of 14. Now, what makes this, I guess, difficult is, like last lesson, you could just type whatever you were given and put it in your calculator. Here you can't. Square root of 10, we get a decimal, like something like 3.2 or something like that. The square root of 20, we probably get 4.5, around there. And the problem is they're going to say simplify it in radical form, or maybe it's an ACT test question and it's 5 possible answer choices, but it's all radical form. Yes, you could manipulate it in radical form and figure it out that way, but it might take you longer than actually just doing it. Now, in order to multiply radicals, first off, these have to be square roots. Like I can't multiply a square root and a cube root with each other. I have to multiply 2 square roots. So I can do this. So I can do square root of 10 times the square root of 20. And that's going to be the square root of 200. And then I know that that can simplify further. And I know this because I know a perfect square that is divisible by 200, and that's 100. And I know 100 times 2 gives me 200. If you struggle with your multiplication facts, you are not going to be a fan of this lesson. You need to be strong with your multiplication facts at this point, or if not, be good with the calculator so you can figure it out. It's one thing that might be beneficial to you if you struggle with your multiplication facts. It might help if you go ahead and write all of your possible perfect squares down, all of your perfect cubes. If you write those down, that's all going to benefit you with this lesson. So, for instance, all my perfect squares, so I'll go ahead and copy those here. But your perfect squares are 1, because 1 squared is 1, 4, because 2 squared is 4, 9, because 3 squared is 9, and so 16, 25, 36, 49, 64, 81, 100, 121, etc. I can keep writing, again, to infinity, because it's whatever squared equals that. So 4 squared, 5 squared, 6 squared, 7 squared, etc. So my perfect cubes is going to be 1, because 1 cubed. 8, because that's 2 cubed. 27, because that's 3 cubed. 64, because that's 4 cubed. I think 5 cubed is 125. Yep, it is. 6 cubed, I think, is 126. Or sorry, 216. 7 cubed, I don't know. 343. 5 cubed. Oh, I did that. 8 cubed. 512. Etc. Okay? Now that, again, it might be beneficial if you have these written down to help you. So basically, I'm trying to find perfect squares of 200 that I can break this into. And you're going to want to use the biggest ones. Some of you might say, okay, I know 200 divisible by 4, that works. You're right, it does, but it's not the simplest form. So you always want to go with the biggest perfect square that can go into 200, and the biggest one is 100. Okay, now some of you might say, okay, why do you write it like that? Because if I have the square root of 100 times 2, I can write this as the square root of 100 times the square root of 2. And the square root of 100, we know is a perfect square, and it simplifies down to 10. So this, in radical form, is 10 square root of 2. That's how that simplifies. Cube roots, same thing. They're both cube roots, so I can do the cube root of 16. I can just do 16 times 20, and that gives me the cube root of 320. So I know the closest thing I could find divisible. It's nothing that's going to be bigger than 125, because 216 is more than half of 320, so it can't be that. So I'm going to start with 125. So I'm going to take 320 divided by 125. I get 2.56. Okay, that doesn't work. So I'm going to do 320 divided by 64. I get 5. So there's my cube. This is going to be the cube root of 64 times the cube root of 5. And the cube root of 64 we established earlier was 4. Because 4 times 4 times 4 equals 64. So the cube root of 64 goes to 4. So this is 4, and the cube root of 5 is how that one simplifies. So let's do this last one. This is the square root of 210. It could be 100, but it's not, because I know 210 is not divisible by 100. And then I'm going to just start with 81. So 210 divided by 81 doesn't work. 210 divided by 64 doesn't work. 210 divided by 49 doesn't work. 210 divided by 36 doesn't work. 210 divided by 25 doesn't work. 210 divided by 16 doesn't work. 210 divided by 9 doesn't work. 210 divided by 4 doesn't work. 210 divided by 1 does. So guess what? This is in its simplest form. It can't be simplified any further. That's it. It's okay if you have that. Let's see what we have here. Okay, this says simplify the expressions and assume all variables are positive. So because it's saying that, we don't have to include the whole absolute value like we did last lesson. So here, the square root of x to the 4th, y to the 6th times 3, square root of 2, x to the 8th, y to the 5th. Okay? So to do this, these are both square roots. So now we have to apply our rules of exponents, but it's under the radical. Okay, so it's going to be 3 times 1, so we'll have 3. And then square root of 2. Notice how I'm not multiplying the 2 and the 3 because I can't. Because the 3 is outside the radical and the 2 is underneath it. And then it's going to be x to the 12th and y to the 11th. Now this can simplify to 3 square root, oh sorry, I did that wrong. The square root of x to the 12th is x to the 12th to the 1/2 power, if you remember from last lesson. So it's going to be 3x to the 6th. I'm not going to have any x's underneath the radical. And then y to the 11th to the 1/2 power doesn't necessarily work because it's y to the 5.5. So that just means that this needs to be rewritten as y to the 10th times y to the 1st. Right? Because I can do the square root of 10, it's going to be y to the 5th. And so then I'm left with the square root of 2y as what's inside. So that is totally simplified. So let's do this. Distribute the square root of 5. Now, when I take this, distribute the square root of 3. When I take the square root of 3 times 5, it's not the square root of 15. Notice how this isn't a square root. So the square root of 3 times 5 is simply just 5 square root of 3. It's like we're doing 1 times 5 and we get 5 and then carry the square root of 3. Just like 1x times 5 is 5x. Plus, now these both have square roots. So I can do the square root of 3 times the square root of 21 and get the square root of 63. And that is divisible by 9. So that can simplify further. Actually, can I use anything else? 49, no. 36, no. 25, no. 16, no. So it's going to have to be 9 and 7. So this goes to 5 square root of 3 plus 3 square root of 7. Well, how did I do that? Well, square root of 63 can be written as the square root of 9 times the square root of 7, and the square root of 9 is 3. And then these, I can't add those because the square root is not the same. Now, if this was 5 square root of 3 plus 3 square root of 3, I could add that because now they're like terms. 5x plus 3x would be 8x. Well, in this case, it'd be 8 square root of 3. So the only time you can add them is if your radical is the same. So here, it's just going to stay like that. They're not like terms. I can't combine them any further. Let's look here. Again, it's square roots, so I can do, they're both square roots, so I can multiply them. So it's going to be the square root of 400x to the third. Okay, so what I would do, I would take the square root of 400, which I actually can, and I get 20. So it's basically 20 and then times the square root of x to the third, but remember we can rewrite that as x squared times x. So the square root of x squared is x, so it's 20x square root of x as your answer. So that's it in simplified form there. And here it is. Here. Let's look at more problems. Now this is rationalizing the denominator. Again, it's the same as simplifying or multiplying, but to simplify a radical, just like to simplify a complex, you couldn't have I in the denominator. Well, to simplify a radical expression, you can't have a radical in the denominator. So we have to get rid of it. And in order to get rid of it is you can multiply the denominator by itself, and that gets rid of it. So if I multiply this by the square root of 2x squared y cubed, remember, if I multiply something by itself, it's like taking it and squaring it. So all that's happening is your denominator is going to 2x squared y cubed. You're just getting rid of your radical. But you do have to actually, what you do to the bottom, you have to do to the top. So we have to multiply the numerator as well. And that's going to be, they're both under the radical, so I can multiply 5 times 2 is 10. So it's going to be the square root of 10 x to the 6th, y to the 4th, which obviously we've learned from the previous couple of slides that that can be simplified further. The square root of 10 can't. 9, 4, and 1 are the only perfect squares smaller than 10, and I can't divide it by any of those, so it's going to stay the square root of 10. We can do the square root of x to the 6th, that's going to be x cubed, and then the square root of x to the 4th is, or of y to the 4th is y squared. So it's x cubed y squared square root of 10 all over 2 x squared y cubed. However, that can be simplified further. Using our rules of exponents, again, that we've learned, we can subtract. So x cubed and x squared, that can subtract. 3 minus 2 is 1x. Y squared minus y to the third, so 2 minus 1 is negative 1, but I can't have a y to the negative 1 power, so I have to move it down here. So it's actually going to be x square root of 10 over 2y to the first power. So this is your final answer for this problem. And then we can do the same thing here. We can just multiply by the square root of 8x. Some of you might say, okay, why aren't you multiplying it by 3 square root of 8x? We could, but it's just going to make us have to do more simplification later on. So doing that, we're going to end up with 4 and then times the square root of 48x all over 3 times 8x. Well, it's really going to be 3 in the square root of 64x squared, but 64x squared can simplify to 8x, and then 3 times 8x can simplify to 24x. Okay, now let's see if the square root of 48x can simplify. My perfect squares I already have listed here. I think 16 might work, so let's try 48 divided by 16, and that is right, 16 and 3 are my factors of 48. So I can rewrite this as 4 times the square root of 16 times the square root of 3 times the square root of x. And the square root of 16 is 4. 4 times 4 is 16. So this is really 16 square root of 3x, because neither of those can simplify, all over 24x. Which again can be simplified further, because 16 and 24 are all divisible by 4. And actually one step further, they're all divisible by 8. So 16 divided by 8 is 2, so it's 2 square root of 3x and 12x. So that is that simplified. And then this last one, let's multiply by the square root of 7. So doing that, we'll get the square root of 49, which is 7. And here it's just like last slide, where we have to take the square root of something and multiply it by, distribute it to both terms. So we're doing the square root of 7 times 3, that's just 3 square root of 7. We're doing the square root of 7 times the square root of 7, which is the square root of 49, which is 7. And so this is really, that's simplified form. There's nothing else we could do. You could, I guess, technically rewrite it as 3 square root of 7 sevenths plus 1. Because really this is 3 radical 7 over 7 plus 7 over 7, which could simplify to that. So on your ACT, it could be written this way or this way. I'm not sure how they would write it, and maybe they change it up for depending on what test it is too. So I know it's a lot, but as long as you've understood everything up to this point, it's really easy stuff. It's just applying everything we've learned to, again, a new concept. See how math is constantly a building block? You're constantly building off of what you already know.